Hello, everyone. My name is Mark Makary. Thank you very much for joining us today. I'm the CTO of Logic Keepers. Logic Keepers is a software solutions and services company. It's based out of Frisco, Texas, and we focus on creating digital advantage for our clients. We really focus on helping with large scale solutions and application modernization. And I guess some of you guys that we worked with you before and you're some of our clients. We're also part of the Confluent Consulting Network, and we are fortunate to be a Lightbend the consulting partner. And I would really like to thank Lightbend for co-hosting the webinar today. And we are really very keen on making sure this is going to be a very good use of your time. So today we are going to highlight a few concepts that I'm really sure that you're going to hear about this for some time over and over again because of the times that we live in today. And as part of what we do every day, along with Lightbend and our partners, that we work through really innovative and interesting use cases, and we learn a lot along the way. And today we are sharing this experience with you. A big part of the challenges that we face today as a community is related to uncertainty and the ability to deal with this uncertainty. Same really applies to the digital world that we live in, and we are going to talk how we can build system that can easily adapt to future requirements. And this is what we are going to cover today. So the pandemic use cases, it's no doubt really that those are challenging times for many of us, and the focus for many businesses right now is to make sure that we can survive this and flourish back during the reopening. But this is really going to be a different different world. We're gonna reopen to a new norm. It's not the older norm that we are used to. Within this environment that have seen the digital to be the cornerstone of surviving for many industries. And what we have in here, just few use cases and few industries, not mind, just the health and the government that really need to respond to that. Retail, of course, is a big one. This one is very important and got hit hard. Uh, a lot of retail vendors right now trying to use technology to reopen. We see use cases like augmented reality and virtual fitting, um, digital dressing rooms and things like that. It happens on the apps. We can see creative stuff like pushing marketing promotion notification to the apps when the users in the mall and close to the store. Stores are counting people using sensors when they come in and try to show on the apps the number of people that they currently in the store physically, just to avoid the big lines and outside and making sure that the customers having a good user experience, and also for safety purposes. Curbside pickup apps and arrangements, this is also a big part of it. Supply chain delivery also need to adapt to this new norm. And there isn't really one solution that fits all. We have to try a few things and see if this works or not. And if not working, that we have to move to something else and see that it's going to working. And sometimes that we try a few things at parallel because we can't really afford to wait on this. On the banking side, that we are adapting to a very heavy load for concurrent users, a high level number of requests coming in, everyone coming in for from the small business side to the pay check program, protection program, or rescheduling payments on loans and things like that. So on the banking side, also they have to come up with creative ways to handle this load shifts. On the financial side, as you can see, trading applications are soaring. Unconventional loans and investment vehicles and being created, payments and contactless solutions. There's also solutions that coming in for supporting exact change because there was some shortage on the change side. So you have solutions that allow people just to tap their credit card or waive it and get charged at a fixed price. So on the entertainment and the media streaming, the streaming load and quality, and making sure that supporting all the people that staying at home for social distancing. And there's really difficult problems in there. For instance, figuring out which quality you're gonna provide and for which content and will be streamed to whom and which device is and the when is not really an easy problem to solve. Um, on the telecommunication side, really supporting all this people that working from home, almost every home now is becoming a business. And then you have to support that kind of load that coming in sometimes on the telecom side that you have to dip into their contingency and their disaster recovery environment, just to make sure that they have the ability to sustain this kind of load. On the gaming side, the virtual reality and simulations, we're getting a lot of use cases focusing on this. There is a very heavy load on chat rooms. People are trying to use this chat rooms to replace some of the social interactions that they had before. And this is really helping with social distancing, but still at the same time that it's a very heavy load on the gaming side that they had to adapt to. Call centers, moving workers to work from home. Some of those call centers that they have people work on site, and to get them to work from home with all the security headache that associated with that is a big problem. So they have to adapt to this, and they have to find out good ways to be able to support that. And of course, remote working and schooling, it's a big deal. I'm sure that you have about 4 or 5 different apps on your machines right now to support this for virtual meetings and collaboration. A lot of things that had to be done on that space to support this huge wave of working from home and school. And there's a lot of things that also been done on that space to make sure that productivity is not impacted in a negative way at all. So there is a lot of things that happening really on those use cases that coming to us every day, and everyone has to adapt to this fairly quickly. And does anyone else that we learned really a few lessons from that during this time? One of the obvious things that we saw in there was the clear advantage of the digital ready companies. So in the last year or so, the term digital transformation became overused, and the hype turned into sometimes even a taboo, like a bad thing. And many people question the need for investing in digital transformation. Right? This is just became something that for enterprise architecture, sometimes in big organization solution architecture as more of a marketing hype. However, fast forward, the pandemic hit and all that changed. People are rushing to invest on the digital side. As you can see that they're trying to adapt to those new use cases. And sometimes that they find out it might be too little or too late. So it's really, it's something that we see a lot of people either that they have advantage with or struggling with if they don't have it and they are not digitally ready. So one thing that we find out is really sticking out of this experience that we just talked about, and I'm sure you just guessed it. So adaptability is really the key in there. So being able to adapt quickly is creating a digital advantage, and quickly is the key word here, right? So you cannot just change things, in 6 months or adding features in long time frame like that anymore. We cannot really afford this. And to be able to adapt quickly, right, and have this digital advantage, you need to have flexibility, right? So flexibility is really the cornerstone in there. And again, that to enjoy this flexibility, You have to have the ability to reform and morph and change very quickly. It's very important, time of essence here. And if you don't have the ability to change, but not just only change, to make the change quickly and correctly, then you don't have flexibility. And we found that those flexibilities, fits in few buckets, but there's really two of those are very important. The first one is the ability to utilize infrastructure correctly, right? So example of that, of the infrastructure utilization properly, you think about it that if you have the ability to scale components independently, right? So you have your modularity and you'll be able to really scale up and down the things that you need or you don't need. So for instance, if you have something like a dedicated COVID-19 chatbot and you want to scale this to meet the high demand for all the questions coming through this chatbot, and you want to do that in a very effective way, you cannot just go ahead and try to scale up a monolith, the whole chat system. You just need to be able to chat just only one to scale up one component in there, right? And also you need to have the ability to scale up and down, right? We cannot afford anymore to leave the lights on while there is no one in the room. And having the ability to, to shift the load from one system to another is very important in this picture. Example of the applications and the business features, this is really the second bucket, is the ability to add business features quickly and change things quickly on the front end and the back end side. So for instance, we were looking for people on the retail side that trying to distinguish essential from non-essential goods in their marketplace, or altering the supply chain workflow to be more efficient on the essential stuff during the pandemic, or even sometimes that we find marketplaces right now, the people are looking, or users or consumers looking for the origin for manufacturing those goods, or where they were produced, right? People were struggling even to find out if they can force or get their vendors on the marketplace to indicate this. So those two buckets, we find out that it's really it's very important to have them in there. So what does this has to do with reactive systems, or the ability really to respond quickly on the digital side and have the flexibility in there? So to explain this, I'm just going to give you a little bit of background on reactive. So reactive architecture, or modern application architecture, and which also include cloud native aspects. It's an architecture manifesto that started with the premise to provide modern application qualities to our systems, right? So those qualities for modern applications, such as being responsive under load, resilient under high volume, can automatically scale up and down, cost effective, and flexible to support faster time to market. And the reactive approach is really smart. It defined those business high values features up front, and then defined and collected the best of breed architecture design pattern to support those business values. And the Reactive Manifesto actually was created, I think it was coined in 2013 by the founders of TypeSafe, which is now became Lightbend, and it evolved a lot since then. However, sometimes people think of this paradigm as just really more of message-driven architecture only. I'll just give you an example. Logic keepers usually give regular corporate modern application architecture workshops for architects and on our client side and partners and developers, and we usually get the question at the beginning of the session, is just asynchronous messaging. So of course this is not the case. It's true that message driven architecture is a big part of this. However, the reactive architecture philosophy and design patterns goes really deeper than just this. So reactive architecture, we focus on isolation and decoupling as a philosophy, right? So, and we have this in different dimensions. So on the time side, that we try to make sure that there is no unnecessary blocking or waiting between one service and another. And that's where we go and use the asynchronous messaging and callback. On the space dimension, we make sure that that the service location is really hidden and decoupled from the consumer. There's service location transparency in there. On the state side, that that we make sure that we don't have a state and resource contention. We make sure that there's no stepping each other's toes in there, and there is no unnecessary blocking or locking on resources. And I guess failure, last but not least, is one of the most important aspects in there. We make sure that the failure in one service is not going to be really cascaded to another service and so forth. So as you can see that, all the stuff really in terms of isolation and decoupling, right? It's at the core of reactive architecture. So how come we didn't notice that before? It's because the significant value that we had in terms of responsiveness and resilience, we usually started to forget about the flexibility and elasticity for reactive, right? We started to forget that isolation and decoupling at the core of reactive, and that really makes reactive architecture a naturally flexible architecture, right? But in the last few months, we found out this is to be of really tremendous help and value. It's something that we had all along, but we really talked about. But it was very much highlighted during the pandemic. Right? Other thing that also we have in there that people think about reactive architecture, just a conceptual, it's a myth. So as a very good example that you have in here, we have our partner Lightbend created a true representation and a very good, solid, and robust implementation of the reactive stack, right? And then this happened to be living in the amazing open source space. And Lightbend is really continuously improving those technology stacks. And right now, I'm going to hand over the presentation to my distinguished colleague, David Ogren from Lightbend, who's going to be able to cover this in details.
Thanks, Mark. I had to get unmuted there. Yeah, I want to talk a little bit about how we take these technologies or take these patterns and build applications out of them. So I'm going to spend just a few minutes talking about my own experiences with the pandemic and how it's affected reactive applications. I'm going to talk a little bit about Lightbend and what we do and who we are. I'm going to talk in a little bit more depth about reactive systems. And then I'm going to do a quick demo just to sort of highlight a few key points of the Reactive Manifesto. My name is David Ogren. I am an architect in Lightbend's Global Solutions Architecture team. And I have had this title of software architect for 20 years or so. And one of the benefits of that is I've seen a lot of disruptive technologies come into our space, all the way back to things like client server, all the way back to sort of the original days of the web. And one of the kind of key aspects of being a disruptive technology is that it's not just a new feature, it is something that changes the way we build applications and manage applications and deploy applications and architect applications, and in fact, even our business models. And so for years, I have been putting this slide into my presentation just as sort of a conversation piece around the fact that cloud has been one of those disruptive technologies, or that it's going to be. That the cloud isn't just a new place for us to deploy our applications, but it's really going to change the way that we think about how to build and deploy and even build our business models. I don't always include this anymore because, as Mark pointed out, this is now a little bit more common wisdom, and we've started to call this this process digital transformation. And again, I understand it's a little bit of a marketing term, but the way I think of digital transformation is this recognition that the cloud is not just going to be a feature, but it's going to transform our businesses to be more digital. And I think Mark really hit the nail on the head. What the pandemic has done is it has pushed a new sense of urgency around that digital transformation. Now, that sense of urgency is different for different companies. At Lightbend, we have a lot of customers in the travel space, and their urgency is around how to save costs, because their businesses have been very negatively impacted, and they have to find ways that they can only pay for their usage, and their usage is way down. On the other hand, I have some other customers that are in the supply chain space, and they've built a company around the fact that they can provide a lot of insight on supply chains overnight. But when you're in the middle of a pandemic, overnight isn't really good enough anymore, and you have to be able to provide that that reaction to a shortage of medical supplies, or a shutdown of a restaurant, or all these kind of supply chain impacts. You need to be able to respond to that within the hour, or sometimes within the minute. And so they're really taking all of their existing services and making them available real time on things like mobile devices. And they're kind of right now in the midst of that transformation from being an overnight company to being a real-time company. And that, I think, is just an example of the kinds of urgency that we're seeing out there, along the lines of what Mark's saying. You have to try lots of things, see what works out, and then grow from there. And so let me take 3 slides to talk about what Lightbend is and how we help people on that journey to be more cloud native and more reactive. And I'll define what I mean by that in a couple slides, but the heart of it is that, as Mark mentioned, we have created a number of open source frameworks. For us, it began with Akka and Scala. Two of our founders were the founders of these two projects. Akka is a framework for building highly performant, highly scalable, distributed, concurrent applications. And Scala is a programming language that is of general purpose, but extremely popular in the big data community. And so we took these open source projects and we built an entire stack for enabling reactive applications on top of that, including things like Play, which is a framework for web applications, and Lagom, which is a framework for microservices, and Cloudflow, which is a framework for real-time streams, and CloudState, which is a framework for building all of these applications with all of these properties in a function as a service in a serverless model. And we take all of these different open source frameworks and we assemble them into a platform. And then we take this platform, this distribution, and we provide all of the services and all of the support and all the enablement and all the training that people need to be successful with that. And so here are some of our customers and some of our logos. And here is a few more on this slide. For sake of time, and because I want to make sure I leave lots of time for questions, I'm not going to get a chance to kind of go through these one by one, but I did want to kind of highlight a couple things, especially as we talk about the pandemic. And that is that, first of all, the kinds of applications we're talking about here are everything from brand new applications like Disney Plus streaming, went from 0 to millions of users, essentially overnight. It was all brand new infrastructure built on Lightbend's technology stack, through Verizon and their online phone store. And that's all, that was an existing application that had a lot of legacy components, so you can't rebuild it overnight, but they did need to make it more elastic and more performant so they could stay up during challenging days like iPhone release days and Black Fridays and things like that. So it was taking an existing application and modernizing it. The other couple things I'd like to highlight on these logos is it's everything from streaming and big data applications like all of the machine learning and analysis around HPE's smart storage solutions, through sort of more traditional applications like Starbucks' commerce platform. And it's across all industries: travel, finance, entertainment, technology, telcos. It's a very broad kind of platform in what it addresses as well. And then the final point I wanted to make on sort of our customer slide is that it is for mission critical applications. These companies are running their core systems on Lightbend. So the streaming in a streaming company, the smart in a smart storage solution, the personalization in a cruise line, which differentiates itself based off of personalization. These are our core systems, and those are the kind of characteristics that Reactive can provide. I promised I'd talk a little bit more about what I meant about cloud native applications. And one of the things I said about disruptive technologies is they're not just adding a new feature, they're changing the way we do things. And in the early days of client server, and I know I'm making myself sound old by talking about this, but in the early days of client server, people rolled out their first applications and they were just, a terminal emulator, and they just took their mainframe application and put it on a terminal emulation on the desktop. And that's okay as a start, but it doesn't really help people take advantage of that infrastructure. It doesn't get any benefits of client server. And the same thing was true for the web. Lots of people, when they first got to the web, they said, I'll just take my existing application and wrap it in an ActiveX control or a Java applet and put it out there. And that's great as a first step, but it doesn't take advantage of any of the unique benefits and challenges of the web. And I saw a lot of people have this problem with the cloud as well too, that they would just take their legacy J2E application or their legacy Spring application and throw it into a container and expect to get the benefits of the cloud. And that's just not the way things work. If you want these advantages that Mark talked about in terms of agility and in terms of elasticity and in terms of efficiency, you actually have to build things that are targeting the unique challenges and benefits of that new platform. And so when we talk about the new platform, a lot of times when you hear people talk about the cloud, they're talking about cloud native infrastructure. And from my perspective, that is a very broad category. I mean, and that's okay, because what we're really looking at is looking at infrastructure that lets us be elastic, that lets us be distributed, that lets us pay as we go, that lets us be software defined and declarative. And how we actually implement that is up to what best fits the organization. That can be a private cloud, or it can be a public cloud, or it can be Kubernetes, or it can be Fargate, or it can be raw ECT nodes. It doesn't matter, as long as it has these characteristics of being distributed and elastic and on demand, and then we can take advantage of that. And that's what Lightbend is. It's trying to build a application development framework that takes advantage of those characteristics. And what technical features do you need to do in order to do that? Well, Mark already highlighted this, and this was something that was published about 6 years ago under the name the Reactive Manifesto. It's up there. There's the URL for it. It's a really short and simple document, but as Mark says, it goes into both the characteristics that modern applications need and then the patterns that you need in order to solve that. Now, today we'd call these modern applications cloud native applications. The Reactive Manifesto never uses the word cloud native, but it does describe modern applications as applications that run on a distributed, on-demand, elastic mesh of services rather than monolithic applications. So it might as well be using the word cloud. I don't want to repeat anything that Mark said, but the things I like to highlight about the Reactive Manifesto is that it is not only these sort of high-level characteristics that, you know, sound good. I mean, everybody's always wanted fast applications and reliable applications and scalable applications, but it actually has sort of specific definitions for what these mean, why they're important for the cloud, and why and how to achieve them. So, for example, when we're talking about distributed systems with a bunch of APIs, you can't have blocking calls. So it goes a lot into the patterns of how to be responsive, even in cases where you are going to be a mesh of services. And the same thing for resiliency. One of the core principles around resiliency is that you're going to have failures in a distributed system. You can't, you know, like you can in a monolith, you can try to prevent failures, but in a distributed system, you have to be able to self-heal. You have to have it baked into the infrastructure, the capability to recover from failure. And elasticity is obviously the core of all the things we've been talking about. And as Mark mentioned, the punchline of all of this is the way to do this is to build things by being message driven. That's not all it is. There's a bunch of additional patterns, but if you are message driven, it gives you a way to be asynchronous. It gives you a way to be resilient because you can just replay your messages to recover from failure. And it lets you be elastic because you don't really care who's processing your messages, just that they get processed. And what Lightbend does and this open source technology stack does is give you all of this by default. So regardless of whether you're building a kind of traditional or microservices application, you can build that on the Akka platform, which gives you all of these responsive and elastic and resilient characteristics. But the same thing is also true if you're taking a batch application and making it real-time streaming. That's something you can do with the Cloudflow platform, again, based off of those same characteristics and same technologies. And coming soon, you'll be able to do the same kind of thing with function as a service with the Cloud State project. And regardless, we're going to kind of give you a unified layer for managing and monitoring that. So I wanted to just do a quick demo of some of these characteristics, and then we will segue into some questions. And to do that quick demo, I sort of needed to pick one of these styles of applications, and sort of so I chose a microservices focused application. And so in fact, what I have is I have a little e-commerce application. It's really simple. It's not here to be an extensive demo. It's just to show a couple of these principles. And so I actually have running on my laptop on a small little Kubernetes cluster, a shopping cart microservice, an inventory microservice, and they communicate with each other via Kafka, so that when I, for example, check out my shopping cart, it updates the amount of available inventory inside the inventory microservice. And then the other thing I wanted to highlight out of this too is that, as I mentioned, one of the important principles of resiliency is that I can just replay my messages if I ever need to recover from failure. Well, my shopping cart actually serves all of its information out of memory. That's how I'm so fast. That's how I can get a lot of flexibility in how I design my service. But when it needs to recover, it needs somewhere durable to replay those messages from. So in case of failure, it needs somewhere to go back to replay things. And we do that by storing those messages in Postgres. And as I'll show you, it's important to note that we're not going back to Postgres with every single request. That would be slow. That would be very legacy. But what we're doing is we're just using it as a recovery mechanism. I'm exposing these via some REST APIs. I'm just doing that because it makes for an easier demo. You can expose it via whatever interfaces you need, gRPC, what have you. And then I have a simple load generator. I haven't started the load generator yet, but we'll start that in the demo here shortly. And then I have a console that's watching over everything. So I'm going to do this demo in two kind of short little vignettes. The first, I want to just show you the demo at a high level, help you understand what's going on, and show how we can scale this up and down. The kind of key things to look for here are that I'm trying to help you understand how the work gets distributed inside a reactive system. And especially how, as we address the elasticity of the system, work can move around. As Mark mentioned, if like this is a chatbot, I want to be able to take this from 300 processing nodes in the middle of the workday down to 3 processing nodes at night, and how does the work get reallocated as it makes those transitions. So let's dive in to take a look at our demo. So this is Lightbend's console. It is collecting information from all of the services we're running, regardless of whether those are real-time streams or microservices or traditional applications or stateless applications. All of that information gets collected here into the console. And because I want to leave a lot of time for questions, I'm not going to do a deep dive on the console. I do just sort of want to highlight a couple key points. First, that I'm kind of, sorry, I'm trying to find my cursor here. Stop my presentation. There we go. So I'm showing some information on the cluster here on the left. And then these are my 2 microservices. And the thing I want you to get out of this is that it's showing me that I have 3 instances of my shopping cart microservices. They are joined together in one cluster, so they can all intercommunicate and are controlled as one deployment by Kubernetes. And then I have 2 instances of my inventory microservice, and they're also clustered together in a separate cluster. I said don't want to drill dive deep too into this, but I can click into this, get the complete timeline. This is the past. This is the current time. I can kind of see I started it up this morning, and I can see the entire history of this service. And I can actually drill down even deeper and say, give me very low level details. Here are my key metrics that it thinks are most important for predicting the health of the service. Here are the details of the internals and how much data it's processing and how fast it's going. Here's how its HTTP metrics are, so I can monitor it from the outside. Here is some details about the cluster and the JVM, and a million other things. So the only things I want you to sort of take away from the cluster is that it's comprehensive. It's showing me everything, and I can go from the very high levels of monitoring to the very low levels of monitoring. I can also take this same data and export it into Datadog or anywhere else that you want to send your data. Since this is so comprehensive, what I actually did is I built sort of just a simple, a more simplistic way of visualizing what's going on inside that cluster. And we're just going to look, and so this is just a hand-built visualizer for me and not our production monitoring tool. It's just helpful for me to explain to you what's going on inside the system. And right now I have I'm just showing you the shopping cart, and I can see that there are 3 nodes in my shopping cart service. And you can see that they're just here and they're telling me what their IP is. And so now let's come in and start using my service. The simplest API I have is one API that just gets the contents of a shopping cart. And so if I just refresh this browser window, it's going to make a request for shopping cart number 20. And if I come back here in just a moment, you will see that what it did is it loaded that shopping cart number 20, there you can see the 20, and loaded that into memory and assigned it to a node. So that shopping cart is now in memory. It will stay in memory. I can process things from it at in-memory speed. So that's where I'm getting that responsiveness. I'm being able to process everything from memory. Let's do a few more requests. I'll do one for 21, for 22, and you can see we're just getting different results for our different shopping carts. But if we now come back here, you'll see that the Akka platform has balanced all of those shopping carts so that they're evenly distributed. It's also smart enough to know that you saw I was making all of my requests to one of the machines, but it's able to automatically route the request to whichever node has the particular shopping cart on it. So it's evenly balanced and across all of these nodes. So what I'm going to do is I'm going to come in here and I'm going to turn on my load generator. And so in a moment here, we're actually going to see this whole cluster get filled up with shopping carts, and all of the load will be evenly distributed amongst my 3 nodes. So while I wait for this to happen and for this to fill out a little bit, let me tell you why this is sort of important. It's important because I can essentially treat the entire cluster as if it's one machine. When I'm processing an API request, I don't have to worry about whether that shopping cart is on my machine or another machine, or whether there's 1 node in the cluster or whether there's 200 nodes in the cluster. If I need more capacity, I just add more nodes. And so now my cluster is fairly full up, and you can see that all of the work is evenly balanced amongst my 3 nodes. To kind of further make the point I made before, if this is too much load for me to handle, I can just come back and add more nodes to it. And so I told Kubernetes to add more nodes. This could be auto scaling, or it could be somebody intervening and saying I need more nodes. I can then, these will take a couple seconds to come up, but pretty soon I will see a couple more orange circles appear to represent more nodes. They'll show up. Let's see if they will show up here momentarily. Once they show up, they won't have any work because they'll be brand new. But then once they show up, Akka will see them, start to allocate new work to them, and rebalance the cluster. I'm just going to refresh this just so that it looks prettier. You can see it's no actual. Let me just refresh it so that it reformats itself a little bit. Maybe I shouldn't have done that. The demo gods are against me. Well, I will go back to our actual monitoring console then and show you that that I do now indeed have 5 nodes that are out there, and I can actually come into the cluster. See if my demo has recovered. I can actually come into the cluster here and show that the work has been rebalanced amongst all of the nodes in the cluster. I'll come back to that in a second, maybe once that gets back to normal. But in the meantime, what I'm going to do is I'm going to shut off my load generator, and I'm going to scale it back down. In fact, we'll scale it all the way back down to 2, because again, part of the point here is that I can scale both up and I can scale down. Turn my data generator back on again. While I wait for that to recover, I will go back to my presentation. And sort of show my next point. So I already sort of talked about how this lets me treat the entire cluster as if it's one big computer, and let that computer grow and shrink as my demand shrinks. The other thing I just sort of wanted to highlight is what Mark talked about as far as isolation, that if other services fail, the microservice can continue. If the database fails, the microservice can continue. If Kafka fails, the microservice can continue. So the way I sort of wanted to show that is to show you a little bit more complex APIs. So here is Postman, which is just a tool for making REST requests. You can see if I make REST requests for the shopping cart, it's still giving me results. But now I can do more complicated things like add things to shopping carts, check out shopping carts. And I can also access the inventory microservice. So I can see what the current inventory is. I can add to that inventory, and then I can see that the inventory has been successfully updated. And the only really parts I wanted to highlight with this part of the demo is that if I shut down the inventory microservice, obviously the inventory microservice isn't going to work anymore, but and so I can see that it's failed because it doesn't exist anymore. But the shopping cart can continue. So this goes back to sort of the agility that I can change each one of these individually and update and manage and monitor and extend all these individually without affecting each other. And so I can continue to operate on the get cart, and then whenever inventory comes back up, it can just catch up on the messages that it received in the meantime. The other thing I wanted to show is that, it can be even more than that. It can even be backend services. Again, one of the things we talked about with Verizon is how can they stay up even with the existing load systems going down. So I can even do things like shut my entire database down. So I stopped Postgres completely, and you can see that my shopping cart microservice still continues because it's still got all of this stuff in memory. It still can continue processing requests. Now, obviously, I don't recommend you shut down your database because now it can no longer recover, but it just highlights the fact that we degrade gracefully. You keep, because you're reactive, because you've got all this resilience, because you've got all of the self-healing, you can continue even when other services, even when other backend infrastructure is completely gone. So just to conclude, what we at Lightbend do is both try to help you use our software, but also help you use it to build systems in a way that meets all of these things that you need to fulfill. It helps you be resilient, it helps you be responsive, it helps you be elastic as the needs for all of your services change. I think Mark really hit the nail on the head. You have to just try stuff and see what sticks. But what Reactive does is helps you not have to worry about how you're going to scale it. If you build that new chatbot service and it becomes super popular, you can just scale it out. If you try something and it doesn't work, that's fine. You can just keep it running at one node. And so we do that with a combination of enablement, with technology, with training, with both developer support and production support, as well as what we call our embedded engineer program, where we basically have an architect help you design and make sure that you're off to the right foot with kind of the fundamentals of this new type of cloud native infrastructure. So I'm going to hand it over to David Loader. He's one of our sales directors. He is going to help us moderate any questions you have. While we wait for any questions that you might have, I'll just reiterate that if you have any questions about the technology side of reactive architecture or how you build this with Lightbend, feel free to reach out to me directly. If you have any questions about Lightbend and our company and how we help people, feel free to reach out to David Loader. And obviously feel free to reach out to Mark and to Logic Keepers as well. So with that, I'm going to turn it back to you, David and Mark.
Thanks, Ogren. Hey, everybody, if you can hear me okay, this is David Loader with Lightbend. Appreciate everybody attending. Hope you found this session informative. I didn't see any questions in the chat, but I would like to open it up if anyone wants to raise their hand or go ahead and speak up or pose a question regarding this material or anything around Lightbend or Logic Keepers. I saw one pop up and then it disappeared, and then I see Jeff Simon. Why don't I see if I can't get your question answered and turn it over to you. Or perhaps you're muted. Mark, is it possible to unmute the participants?
Yeah, let me work on that.
Bear with us a sec, folks, and we will try to get you unmuted. In the meantime, if you want to try to type your question in chat, Jeff, I'll try to read that out loud and see if we can't answer it for you. The one question, there we go. I see it in Q&A now. So I see a question from Prasenjit Mandal. Let's say I'm migrating a bunch of apps to a K8s cluster hosted on AWS. I can very well achieve whatever you showed by installing, a Kubernetes or K8s dashboard. What are the advantages I'm going to get specifically?
Let me take a swing at that, and then maybe Mark, you can add some of your comments as well too. I think it comes back to my point about the difference between, say, deploying something to client server and web and something that's native for it. If I just take an existing application and throw it onto Kubernetes, it has no way of coordinating any of its state or any of its various attributes other than, say, some external source such as a database. So it's hard for me to scale it, make it resilient, have all these properties that we talked about with the Reactive Manifesto. I can monitor it with the Kubernetes dashboard. So console is nice because it shows me a lot of low-level details that are application specific, but there's nothing magic about console. Console's just showing me another view of what's inside my Kubernetes cluster. The real magic comes from the reactive elements from it. Its ability to run even without the database, its ability to communicate with and load balance with all of the other elements inside the cluster. It's a difference between clustering at the infrastructure level and clustering inside of your application. Anything you wanted to add to that, Mark?
Yeah, absolutely. So I think monitoring is one aspect of it and responding to that, but also on the design of the actual architecture and being able to use the proper components in there. So we see a lot of people that suffering from the problem of the microservices spaghetti right now with tons of microservices in their environment, and they're really looking for other ways where we'll be able to build more of microsystems and using the actor model to to make sure that we are not overwhelming the system with that number of microservices that we are throwing in there. So the Akka toolkit and all those utils in there allow us to create workers in a simpler fashion without overwhelming the system. Also, self-healing and having the ability to do that on the application framework side is very important. It doesn't need really to go to the Kubernetes layer if we don't need to. We should be able to handle this in a more of a proper business response fashion versus something that we do on the infrastructure like an alert or so. So I think that's the design and architecture aspect of it is a very important aspect too, not just the monitoring.
Yeah, that's a really good point. I've done a recent talk on microservices, and you're right about what you just called the service spaghetti and what I sometimes call the wheel of doom. There is this important distinction between these sort of like big high-level coarse-grained services and the kind of very low-level services you can provide inside an Akka cluster. So one of the other specific things you get is this ability to essentially create an object and have object level kind of precision and small functions that are able to inside that cluster, and I'm able to sort of treat like services, but without all of the heavyweight and complexity and additional overhead of deploying them as a separate service into Kubernetes. Great question.
So I think that also a follow-up comment on that, David, you wanna pick this up?
So the follow-up question was, can I take action from within inside the Lightbend console for scaling up and scaling down, things like that? No, actually, you can't. That would be a great feature to add in some ways, but one of the things it is designed to use the underlying infrastructure of Kubernetes for that. And sort of brought up the Kubernetes dashboard, and if those are the kind of things that you want to do, be able to take action or edit a YAML or things like that, the Kubernetes console is probably of whatever flavor of Kubernetes distribution you use or Fargate or what have you. But what really the idea of the console is to provide things that are unique to the reactive side of things. So yes, it's showing me kind of like a high level view of Kubernetes, but the real value of the Kubernetes of the Lightbend console is that I can drill into it and see this super low level detail about how many actors are there and how many messages are they processing in your kind of business level details, rather than just the high level things. So we can differentiate more in the console by focusing on the reactive technologies rather than trying to be a generic Kubernetes management tool. As was pointed out before, there are lots of great Kubernetes management tools.
Great. Thanks, David Ogren. David Loader again here. I don't see any other questions posed in the Q&A. If you do have questions, it looks like that is the best way to ask those right now. Let me just open it up to the participants again. Is there any other questions regarding presentation or adjacent technology? Got the follow-up there. Basically, it helps enable reactive aspect of it. Yep. Thanks.
Yeah,
Great presentation.
I agree.
Yep. Thank you for that feedback on that. I'm glad you found this information valuable. Let me just ask again, is there any other individuals out there that would like to dive deeper or ask any other adjacent questions while we still have some time left here?
Well, just in case we don't, I do want to thank everybody for joining. I do, this is a motto I've had for a long time, and I think it aligns well with what Mark said as well too. I think there is no way to say how the pandemic's going to affect us in 12 months. There's just too many unknowns. And so the only thing we can do is react with urgency, start doing something, even if it's something, but start small so you can adjust your course as you go, and then sort of have this plan for how you scale it out if you need it. So if there's nothing else, David, Mark, do you want to?
Yeah, thank you. Thank you very much, David, and thanks Lightbend for co-hosting. It's really great. I just want to quickly mention in there that it's an open source model. We like to help. Please don't hesitate to reach out to us or Lightbend. You just have to find us. It's great to have you. I want to thank everyone for participating. This is great. Thank you very much.
Thanks very much.
Thanks, everyone.
Have a good day.